Namaste. Welcome to tutorial series on SuperPro Designer for Beginners, step-by-step guide to process simulation. In the previous videos, we learned how to set up this mixture preparation procedure, which is part of the streptomycin production process. And also, we have studied how to kind of initiate this shake flask along with production fermenter, different steps as well as different operations available in this particular process. When you see this streptomycin production process further, the whatever the fermentation broth is coming is sent to a reactor. In this reactor, the streptomycin is getting converted into streptomycin sulfate by addition of sulfuric acid. And also, if you could notice the operations available, the broth is transferred in, and it has been like sulfuric acid has been charged. Charge indicates that here they have not used the charge operation, the pull-in operation is used because 20% sulfuric acid is added on some criteria, based on some criteria. When there is a criteria, definitely you cannot go with transferring option or like charge option, you go with pull-in operation. Once the sulfuric acid is added, further the reaction is carried out to convert streptomycin to streptomycin sulfate, and once this reaction is completed, cellite is added. Basically, cellite is a diatomaceous earth which is used as a filter aid to improve the efficiency of the filtration process when there are too much of fine particles. So to kind of reduce the improve the efficiency, they add this diatomaceous earth. So once this cellite is added, the filter, like whatever the reaction mixture composition is there, it has been sent to the filter. So in this particular filtration system, that is rotary vacuum filter, you can notice there is one operation, that is filter operation is available, so which removes the biomass and cellite from the system. So as we are using the demo version of the tool, so we cannot add more than two operations, two procedures. That is the reason I am just going two procedures in each tutorial. So in this tutorial, let us simulate this sulfation process as well as cell removal process. Yes. So I have just formulated a problem statement based on the information available in this two procedure, that is sulfation procedure as well as the filtration procedure. So upon completion of the fermentation steps, 60,000 kg of broth with the following composition is sent to an adiabatic reactor for acidification. So you can notice the composition here. And streptomycin reacts with 20% sulfuric acid solution, that is like mass ratio is 0.255. Let us see what is this mass ratio. Forming streptomycin sulfate. A 6 hours reaction time was assumed with a conversion of 98%, represented by the following mass stoichiometry. The stoichiometric equation is also given, that is 2 streptomycin plus 3 H2SO4 gives 1 streptomycin sulfate. And after completion of acidification, diatomaceous earth, that is cellite, is added to the reactor to a final concentration of 2% weight by weight. The role of cellite is to aid the subsequent filtration and removal of mycelium by a rotary vacuum filter. The filter cake is washed with water to minimize the product loss. So this is the basic problem statement. Let us go and let us go further and simulate this process. Very important step is that we need to register the pure components. So I have already registered all the required pure components for this simulation purpose. That is, ammonium sulfate is required, it is already available in the database, it is registered. Cellite is not available in the database, so we registered as a new component. And glucose is available, sulfuric acid is available, nitrogen, oxygen are default components, sodium chloride is registered, biomass is registered, and it is renamed as streptomyces greases. And soya hydrolysate is registered as a new component. Streptomycin again is registered as a new component, and you should notice one more thing, that we need to change the molecular weight of this streptomycin because it is registered with the water properties. This is very important because we need to set up the stoichiometric equation in the later stages. Okay, so as the stoichiometric equation is a mole balance, it is not a mass balance. Definitely it should match with the molecular weight, because 2 streptomycin and 3 H2SO4, this particular mass should be equal to like the left hand side. So moles are not conserved, but mass is conserved. So that is the reason. So we need to add this molecular weight of streptomycin, and also streptomycin sulfate molecular weight is also added here, that is 1457. Rest all the properties we go with the default values. So all the required components are registered here. So what is the first procedure required is a react procedure, because it's not fermentation. Fermentation is already over. So we use a react operation. And once you use a react operation, so we can add this particular streams. First we need to transfer the broth. And once the broth is transferred, we need to charge the sulfuric acid. So once the sulfuric acid is added, the reaction is carried out. The next one, we need to add the salite. Once the salite is added, we transfer out the ingredients to the rotary vacuum filter. So let us add one more procedure, that is filtration, rotary vacuum filter. So whatever this fermentation broth, reaction mixture coming from this vessel is sent to this particular rotary vacuum filter, and filtrate is coming out of this particular stream. And is also mentioned that water is used to wash the cake, so we can use this water. And this is the cake stream. You can notice that when you place a cursor, you can notice cake is coming out of this stream, and whatever the water is used for washing purpose, that is also coming along with the filtrate. So this is the required stream, and let us rename the streams for better easy purpose. This is 20 per, this is broth, and this one is 20% sulfuric acid, and next one, this is salite, and this one is water. This is cake. This is filtrate. Yes, this is reaction mixture. If you want, you can also rename this reaction mixture. So required streams have been renamed. Let us charge. So broth, you can do one more thing. So directly you can add the components in this broth stream, whatever this, for example, 7 components are, you can add. And the flow rate is given, that is 60,000 kg is charged per batch, and you can mention the mass composition. Otherwise, we can also register this broth as a stock mixture. We can register the broth as a stock mixture, and it appears in the stock mixture here, and you can just add it. But I'll go here with just charging with all the individual components: ammonium sulfate, then glucose, NaCl, streptomyces greases, soya hydrolysate, streptomycin, and water. So these are the required components. And what is the flow rate? That is 60,000 kg. And mass composition is given, that is ammonium sulfate is 0.1, and glucose is 0.4, and NaCl is 0.22, streptomyces greases 3.5, and soya hydrolysate is 0.04, streptomycin is 4.1, and water is 91.64. So we have added all the components. You can notice the flow rate of individual component is also calculated. Rest all we go with default value. Click OK. Next one, we need to initiate this particular stream, that is sulfuric acid need to be charged. So and the sulfuric acid required is 20%. So here we don't know how much need to be charged, because based upon the broth quantity, so based upon some criteria, the sulfuric acid will be charged into the system. So that is the reason sulfuric acid is not charged here. Sulfuric acid is pulled in, so using some advanced options. So it is 20%, and this is 80%. And as I already told them, we don't know the quantity, so we just go with auto adjust. The moment you select auto adjust, automatically you can notice it is changed to 100 kg, but later post calculation these values will change. And also we need to add the salite here. The salite is already registered, and again it is mentioned 2% salite, but we don't know the final reaction mixture, because we know the initial 60,000 kg of broth, but later during the sulfation process, the some quantity of sulfuric acid is also drawn. So based on the total amount, we need to add the 2% of the salite, but we don't know that mixture. So again it is auto adjust, and it is 100 kg per batch, but later the post calculation, again these values will change. So these are all the input streams. Again this particular water stream need to be initiated. And cake washing, again we don't know what is the quantity of water required to wash the cake. Basically depend upon the later cake generation process, then according to the requirement it will be drawn. So we have set up all the streams, then let us add the operations. What are the operations? When you see the streptomycin flow sheet, you can understand there it is transferred in, because it is an intermediate stream, it is transferred in. But here in this case we will charge it because newly kind of we are adding the first input. Once it is charged, we need to pull in the sulfuric acid required content, and next one we need to react it using the stoichiometric batch stoichiometric reaction. And once the reaction is done, we need to pull in the cellite, because that is 2% cellite is required, and later we need to transfer out. So these are the 5 operations is required. And if you see the main process flow sheet, you can understand there is something called as CIP, clean in place is also added. If required, it could be added. So next one here, in the rotary vacuum filter, already it is a continuous process, one operation is available, you don't need to add any operations. So let us initiate these operations in the reactor. First one is charge operation. How much we are charging? So already initiated in the broth stream. So I'll just select user amount on the stream. You can notice it is appearing here. And if you want, you can add some setup time of 5 minutes, and we will have the process time of some 10 minutes. So based on this 10 minutes, automatically this flow rates are calculated. Later you can notice the changes in this particular flow rate. And the next rest all we go with the default values. Next operation is a pull-in operation. So here the pull-in operation is we need to pull the sulfuric acid, that is 20% sulfuric acid. So it is not available on the stream because the quantities are not mentioned on the stream. It is auto adjusted. So we cannot use this particular option. Again, the mass we cannot set it because we don't know how much mass is required, how much volume is required, we don't know. We go with advanced option. Here if you go to this advanced option, in the problem statement it is mentioned the mass ratio. The mass ratio of what? The basically now the reactants are like sulfuric acid and the streptomycin. These are the reactant content. You can easily calculate what is the mass present here. And also in the software itself it mentions initially when you initiate the broth, you know how much quantity of streptomycin is produced. According to that, sulfuric acid need to be added. So here the mass ratio is given is 0.255, and this mass ratio, what is this mass ratio? Amount added to reference amount. What is the amount added? That is sulfuric acid added divided by the reference amount is streptomycin is equal to 0.255. What is the meaning of it? Approximately 0.255 is nothing but 1/4. It is so broth, the sulfuric acid, when you equate it to streptomycin, it is almost 4 times, or the sulfuric acid like requirement for the broth is 1/4 of the streptomycin, 1/4 of the streptomycin. But here it is just 0.25. That is what basically it explains. Means the sulfuric acid requirement is 1/4 of the streptomycin based on the mass ratio. So you can increase these quantities also if you want to add more acid, but adding more acid becomes again you need to invest more on neutralizing the content. So this is the mass ratio is set to 0.255. And what is the added amount? What is the added amount? Here the added amount is sulfuric acid because that is the reference component, and reference amount we will go with initial contents available in the broth. And here the reference amount option, what is the reference component here? Reference component is streptomycin. So this is the reference amount like added amount, that is sulfuric acid, and reference amount is streptomycin. So these are the reacting components here, and it is set. So click OK. Rest all we go with default values. And the flow rates you can mention the options like the setup time of 5 minutes, setup time of 5 minutes, and also you can set the process time for 10 minutes, process time for 10 minutes. So once it will draw within 10 minutes, and once this is pull-in operation has been done, we go with a react operation, that is basically the reaction taking place at adiabatic conditions, and we need to add the reaction. So what is the reaction? That is streptomycin reacts with sulfuric acid which is giving you the streptomycin sulfate. So again we need to go with it is not like balanced. You can notice 679 and 1457 mass is not balanced. So we select the molar, and the stoichiometric equation is given, that is 2 streptomycin plus 3 sulfuric acid now you can notice both the side it is balanced, almost equal. So both the side it is balanced. Click OK. And also reaction conversion is set as 98%. 98%. So this is done. Next we go with transfer out that salite. We need to add the salite. Again we need to use the pull in operation, salite, and we don't know how much need to be added because it is mentioned just 2%. We don't know the post sulfation that reaction mixture quantity. So just that is the reason we go with this advanced option. Click setup. In this time we use this set for final concentration because the salite concentration is given. It should be final concentration should be 2%. So what is the component? That is salite is the component, and we need to set it as 2%. So we need to add the 2% salite. Click OK. And the next operation is the transfer out operation. So reaction mixture need to be transferred out, and here it is we need to set up based on master slave relationship. Why? Because the flow rate of this transfer out stream is purely depend upon the filter process is happening in the rotary vacuum filter. That is the reason you go with the setup, and master procedure is rotary vacuum filter. Master operation, single operation is rotary vacuum filtration. That is filter operation in the rotary vacuum filtration. So click OK. So one more thing, it is like reaction is taking place for 6 hours. In the reaction step we need to set it up 6 hours. Here it is just 60 minutes. We go with hours, and it is for 6 hours. It is for 6 hours. So rest all the information we added. Click OK, and let us set up this filtration operation. So here you can notice it is asking for particle component retention, because as a rotary vacuum filter on the drum like a filtration on the drum, the solid materials will be retained, and liquid components are like which are the components soluble in liquid will be taken out. So in this case salite need to be removed. It is 98% removed, and also this particular biomass it is 100% removed. So these are the two components are retained on the drum as a cake, and rest all are soluble, and it is going along with the water. And this loss on drying, all these components you go with the default value. And in this particular process, if you see, they have set it volume per volume of cake it as 1, volume per cake volume it is used as 1. And also the filtration is carried out for 8 hours. Filtration is carried out for 8 hours, and you can notice we are already connected the water stream to this wash stream. So you can notice this is already cake wash stream is selected, and rest all we go with the default values. And let us solve the material and energy balance. So if you click on this solve material and energy balance, you can notice it is process explorer, updating process explorer done. Yes, material and energy balance ended successfully. So there are no errors in the system. So if you could notice how much quantity of sulfuric acid is added, you can understand here 3136 kg of sulfuric acid is drawn from this particular stream, and sulfuric acid is basically present 627 kg. And it is also mentioned 2 kg like 2% salite. According to that 1290 kg of salite is drawn here. And you can notice that multiple units is added. The reason behind is that the output is 65,000 kg, and initially it is taken along with the default properties that equipment data as design mode, and the maximum volume is 40,000 liter, and only 90% of vessel is used. That is the reason that is not sufficient. So based upon that, the volume calculated in each vessel is 35,846.90. That is the required volume. So double one, it is almost 75 or 72,000 liter is required. That is the reason 2 units have been used here. And if you could able to see this cake stream, you can notice that salite is there, streptomyces griseus is there, and water. And also you can notice in this filtration stream, salite is there. That is 2%, like 98% is only removed. So 2% you can notice is available here. And you can also see still some quantity of streptomycin is available. The reason behind this is the reaction conversion is only 98%. So remaining 2% is coming here. So this is the output composition. And also if you could want to know this reaction mixture components, you can check it here, and we can understand how much amount of water is drawn. So it is almost 5,491 kg of water is drawn, and even you can notice this filtrate stream, so the component is coming out. So this is basically initiation of the reactor and rotary vacuum filter operation. So I hope you understood how to set up these operations in this particular flow sheet. Thank you for watching. Please do not forget to subscribe.